In math method, you you have to know how to sketch this kind of graph, y equals to square root x, and I can also label it as x power of half. Okay. Okay. Similarly, if I have x power of 1/3, I can label it as cubic root of x. If I have x power of 1/4, I can label it as something like this. Okay, they are the same thing. And by the way, in math method, you don't have to know how to draw this kind of graph. You only have to know, even in year 12, all you need to know is how to sketch y equals to square root of x. Okay, you don't have to worry about it, but you have to know how to label them. Okay, these things you have to know. You don't have to know the sketch graphs for those stuff. Okay. Now I'm going to just to show you the standard graph of y equals to square root of x. Okay. The graph start from the origin and it would look like that. Okay, and it will continues keep increasing until x is infinitive and your y will be infinitive. Okay, so this is your y equals to square root of x, and the domain is square bracket from 0 to infinitive. Okay, or you can label it as x belongs to all the positive value union 0. Okay, because origin is included in the standard graph. Okay. Now we can sketch the complex form of square root graph using the standard graph by the method of transformation. Okay, I just do an example here. Okay. So, for example, if someone asks me to sketch the graph y equals to, let's say, okay, square root of minus x plus, okay, let's make it minus x minus 2 and plus say plus 5. Okay. Yep. Okay. The first step is always describe the transformation. Okay. From the graph, I can say okay there's a reflection. Okay, compare with the standard graph, there's a reflection there because there's a minus number times x, and so there's a reflection on y-axis. Okay, we did this in the chapter of transformation. Okay, if you're not sure about it, please go back to transformation videos. Okay. After reflection, I can say there's no dilation. So let's do, and the next step after dilation is translation. Okay, so I can say two translations here. Okay, and it will be moved 5 units up. Okay, and there's horizontal translation. To find the horizontal translation, we have to make whatever in the bracket equal to 0. If there's no bracket here, we can always end the bracket around x. Okay, we only end bracket around x. Okay, don't bracket this because this cannot be 0. 5 doesn't equal to 0. Okay, there's no variable inside. Okay. So I have minus x minus 2, okay, equals to 0, and x is going to be minus 2. So I will have horizontal translation 2 units left to the left. So now let's draw our new graph. X is here, y is here. Okay. And let's picture the shape of the graph first. When we have a reflection on y-axis, so the shape of the graph would become something like this. Okay, something like this. And the starting point doesn't change. Okay, the origin, well, it still starts from the origin. And when we moved 5 units up, so the whole graph move 5 units up, so the starting point would also move 5 units up. And when it moved 2 units to the left, okay, let's say 5 units up, the whole graph moved 2 units to the left. So also the starting point there is going to be 2 units up left. So the new starting point of the graph is going to be somewhere. It's moved 5 units up and 2 units to the left will be somewhere there, which is minus 2 and 5. Okay, 5 and minus 2 there. So the graph would look like that. Okay. From the graph we can say also with a colored dotted circle. Okay. From the graph we can say the domain is the domain of the graph. Sorry. Okay. The domain of the graph is x belongs to, okay, from minus infinity to minus 2. Okay. Again, always label the domain when, especially the domain is not given in the question. Okay. And from the graph we also can say there's no x-intercept and y-intercept. Well, if there's any, you can find it. You can find your x-intercept by assuming y equals to 0, and your y-intercepts by assuming x equals to 0. Okay. 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 Thank you.